before we finish off 6, 7, and 8, as we did 1 to 5 yesterday, what's that graph?
Sine.
Y equals sine x, right? Okay, so there's sine x. So here's the characteristic you're interested in, right? Here's a nice little orange midline with a red line. There's no politics in here.
Why does it say Harper on
it that
the
way? I'll tell you in a minute. This is the starting point of a sine curve. So what you do, to find the start point, you look on the y-axis. If it's a sine curve, it's where y-axis meets midline, and it's going up. Okay, so a positive slope or it's heading up. Okay, that is a positive sine curve, right? Y is equal to sine x. If this curve gets shifted, so for example, if I type in this, I can't actually type anything in. Okay, so what did the minus pi over 4 do?
Right pi over 4?
Took it right pi over 4. So here's the deal. We have two curves, right? We have sine and cos. The only difference between sine and cos we have already figured out is phase shift, right? But in addition to sine and cos, we have a positive sine and we have a negative. We have reflected sine, okay? So this, if I'm looking for the equation of this and I say, give me the equation with a minimum phase shift, then you say, well, okay, y-axis, midline, there's your phase shift, it's right, you can scale it, right pi over 4. I'm going to express this as a positive sine curve shifted to the right pi over 4. Okay? But there's other curves, so there's this curve. This is a reflected sine curve. So it starts at the midline, intersecting the y-axis, going down, right? This is y is equal to negative sine x. Okay? If I shift that, same deal. Well, let's just do a plus this time. Plus pi over 4, 3, whatever. And if I ask you, give me the equation with the minimum phase shift, you look at this and you say, well, okay, if I go there, I'm at the midline going down. It's a reflected sine curve, right? Or maybe I say, give me the equation in the form y equals a sine bx plus c plus d, where a is less than 0. Then you say, okay, then my start point has to be midline going down. There's the start point, and it's left pi over 4, so that'd be theta plus pi over 4, right? Or x plus pi over 4. Okay, two other curves to look at, and I'm not going to do anything fancy with these. I'll just show them to you. This is the cosine curve. It starts at a maximum and goes down. And this is a reflected cosine curve, starts at the minimum and goes up. Okay? So you basically kind of need to know four things, right? Y equals sine x. Y equals negative sine x. Y equals cos x. And y is equal to negative cos x. Okay, so I ask you, what's the equation? I can ask you as a sine curve, a reflected sine curve, a cos curve, a reflected cos curve. I can ask for all four of those equations. If you graphed all four of them, they should be the same. And how do they differ? What's the only difference between any of these guys? Different phase shift, right? Amplitude's all the same. Amplitude is A. If I leave A the same but make it negative and reflect it, B isn't the period, but the period is 2 pi over B. D is the median, The equation of the midline is y equals b. So the only difference between a sine curve, reflected sine curve, cos curve, reflected cos curve is whether or not the a value is positive or negative and the value of c. Okay, so that's going to lead into what we're doing here. Use the graph shown below to complete the following questions. So the first thing I do is just, I like the midline, right? So figure out the scale. This is ones. 1, 2, 3, 4, 5, 6. Middle, 1, 2, 3. So the middle is here. That's b is equal to -1. Being as I counted 1, 2, 3, a is equal to 3. Period comes off of, yeah, oh thank God we've got back to a scale of 12. So the period is from here to here, or from here to here. Okay, so we just got to count it out. I go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what's the period? Pi. Period is pi. Okay, so the amplitude is 3, the period is pi, the vertical displacement is down 1. The minimum phase shift that is the graph of a sine function. Okay, so y-axis, midline, do I go left or right to get it to be a sine function? Sine function. Do I go here or here or here?
Left.
Go left to here, okay? So let's mark that. We'll just put a little square around here. Say that's the start point if it's a sine function, okay? Let's just put a little square here to say, hey, that's what we're doing. And what is that phase shift? So where are we going? 1, 2, 3, 4. So what's phase shift? Left. Now you're not going to say 4 pi over 12, surely. So we're going to say left pi over 3, right? We're going to count 4 pi over 12, and then we're going to reduce it. So if you go left pi over 3, you are a sine function. How do I know? So starting at the y-axis midline, I want to go along the midline, finding the first point, closest point, where the graph is going up. Okay, so y-axis midline, that's here. I want to go along the green line until I find, so it's either here or here. If I go here, that's a reflected sine curve, right? So, minimum phase shift, guys, is a sine curve, reflected sine curve. Okay, so reflected sine curve, that's this guy. That's the circle. Okay, so put a circle down here. It's reflected in the x-axis, right? That says x, not theta. Remember, the reflection takes place before we shift it down 1, right? So, reflected sine curve, again, y-axis, midline. From the midline, I want to go left or right. So I know, having just looked at this with you guys, a reflected sine curve starts at the midline, goes down. This is 1, 2. What am I going to say it is?
Pi over 6.
Right pi over 6. Minimum phase shift of the graph is that of a cosine function. Where does a cosine function start?
Maximum.
Maximum. So it's here. Okay, how shall we indicate it? Let's do a diamond. And what is that?
Left pi over 12.
Left pi over 12. And the minimum phase shift graph of the reflected cosine. Where does the reflected cosine start? So here, okay, so now I got to figure out which one of these is closer. Right? 1, 2, 3, 4, 5. Right.
So always pick the closest.
Yeah, pick the closest, right? The minimum phase shift, right? So you could go right 5 pi over 12, you could go left 7 pi over 12. It would be the same, right? What are we going to use for a shape here?
Triangle.
Triangle. Oh, I like that. Yeah, there we go. Triangle. Okay, so what do we have here? We had a diamond. And here, it's like those diamond-shaped shreddies, right? Manufactured in a special facility. And okay, what did we do? Oh, we said it. We went right 5 pi over 12. Okay, having done all that, did the amplitude change when we went through all this stuff? Nope. Did the period change? Nope. Vertical displacement change? Nope. All right, therefore, the absolute value of A. So what's the absolute value of A? So the absolute value of A is the amplitude, right? A is for amplitude. Is 3. Let's do B and D. What's B? So B is 2 pi over the period, right? What's the period? Pi. 2 pi over pi is 2. D. What's D? Negative 1. Okay? So A, B, D, right? So I always do D first, right? I just count, say D. And actually, once I've done the counting, I've got A, right? Because I go, what is divided by 6? Okay, divide that by 2. I really get A first almost, and then count up to or down to D. All right, what is C equal to if it is a graph of a sine function? Now, remember, equation is this, right? Y equals A sine B bracket x minus C plus D. So if I want it to go left pi over 3, then what is C for a sine function? So if I want to go left pi over 3, I'm going to need it to say theta or x. Sorry, it's be an x, right? Yeah, there's an x. I need to say, whoa, colors. I need to say x plus pi over 3, right? So it's going to be x minus negative pi over 3. Okay, if I want it to be a reflected sine curve, what am I going to put? Pi over 6. I want it to be x minus pi over 6, right? X minus, it's going to move to the right pi over 6. If I want it to be a cosine, minus pi over 12. And if I want it to be reflected cosine, 5 pi over 12. Okay, so we have 4 equations. Okay, I just need to see my values for A. So A, B, and D are what they are, right? So y is equal to, so the positive sine equation, y is equal to positive 3, right? It's not the reflected sign. So positive 3, sine was B. I'm just going to copy it off here because I can't see. I can't see. 2 bracket x plus pi over 3. Yeah, minus 1. Okay, so C is negative pi over 3. I've got x minus negative pi over 3 is x plus pi over 3. The reflected sign, y equals negative 3, right? Amplitude's still 3, but I'm doing a reflected sign, so I'm putting a negative there. Sine 2 bracket x minus 1. Okay, now I fill this in. Right, what was it? Just pi over 6. Minus pi over 6. Cosine equations. Y equals 3. So the positive cosine. So 3 cos square bracket 2 bracket x. Here, I'm going to fill this in. Y equals negative 3 cos 2x. Right? Because A, B, and D are the same, right? Except A here is positive and A here is negative, and then 2. Okay, so for cosine, it's going to be plus pi over 12. And for a reflected cosine, minus 5 pi over 12. So if you took your graphing calculator and graphed these 4 functions, what are you going to end up seeing in the end? Same line 4 times, right? So it will work nicely on the color one because first you'll see it draw like a red line, and then over top of that a blue line, and then over top of that a black line, and then over top of that a whatever line. Okay. We don't have time, so I'm not going to do it. But you know, if you want to convince yourself that they're all the same, just go type these in, the 4 equations. And even if you're just using a grayscale calculator, hit enter and just watch. It's just gonna, right? All you're ever going to see is just one line, unless you messed up, and then you'll see more than one line. Verify 2 of the equations. Okay, which 2? What would you like to verify? We'll call them 1, 2, 3, 4. 1 and 4, fine. 1 and 4. Okay, so to verify equation 1, okay, let's just call it 1, 2, 3, 4. Okay, so we're going to do equation 1. So we're going to say y. We're going to say negative 4 is equal to 3 sine, square bracket, 2 bracket, 5 pi over 12 plus pi over 3 minus 1. Okay, so we're going to substitute in. We're just going to work this down, and if it ends up saying negative 4 equals negative 4, we're going to say, huzzah, right? We verified it. And if it doesn't, we're going to say, mess something up here. Okay, so negative 4 is equal to 3 sine 2. Okay, so what's 5 pi over 12 plus pi over 3? So how many pi over 12s is pi over 3? It's going to be 4 of them, right? Okay, so we're going to get 9 pi over 12. And what's 2 times 9 pi over 12? I mean, it's 18. What does it reduce to? All right, wow, so, okay, 9 pi over, what's 9 over 12 reduced? 3 over 4? So times it's 3 pi over 2, right? So it's going to be 3 sine 3 pi over 2 minus 1. Okay, now, slight pause. I use the unit circle if I need the pi over 6s, the pi over 3s, the pi over 4s. I don't use it so much when I need the pi over 2s. So I do this. Okay, pi over 2, 2 better. So 3 pi over 2 is negative 1, right? I just do a quick little sketch of the thing. That's pi over 2, that's 3 pi over 2. So this is negative 1. So negative 4 is equal to 3 times negative 1 minus 1. Negative 4 is negative 4. Check. Okay, so that works, right? That. And then we were going to do number 4. I'm going to show you a different way. The left side of that equation is y, and the right side of that equation is negative 3 cos 2 bracket x minus 5 pi over 12 minus 1. So the left side is negative 4. And the right side is, so here I'm working the sides separately, right? I'm just keeping things separate. We're going to do a lot of this coming up when we start doing identities, okay? Where we have this T table and you just keep things separate. You can't go crossing over here. There's sometimes a tendency to, oh, let's add 1 to both sides on it. We don't really want to do that. We just really want to work the sides separately. So this is negative 3 cos 2. Okay, x is 5 pi over 12, so we got 5 pi over 12 minus 5 pi over 12. So what's 5 pi over 12 minus 5 pi over 12? 0 times 2 is 0. So we get negative 3 cos 0 minus 1. Cos of 0 is 1. So that's negative 3 times 1 minus 1, which is negative 4. And when these two sides are the same, we put a check. Yes, it works. So there's an algebraic verification, right? If you have to verify algebraically, you just substitute the point in and work this out, aiming for a true statement. Or you can separate this, left side, right side, work each side separately. There's nothing to work here, right? You're just writing the value. But then work this side, aiming for negative 4. Okay, questions? Right? So, if you got a moment, you really want to look at it, just graph all of these. Set a window so you can see this. Go like negative 2 pi to 2 pi and negative 4 to, set the window to match this. Because then all you should see is this one curve, even though you've graphed 4 separate equations. Use the graph shown below to complete the following questions. Okay, so what's the first thing that I'm going to do? Figure out the scale, right? Make sure, because sometimes the scale is halves, so we don't want to count. Okay, so we got 1, 2, 3, 4, 5, 6. So the midline's at 1, 2, 3. So D is equal to 2, and and A is equal to 3. You can also work those out by calculating, right? D is max plus min over 2. It's the average, right? It's in between the max and the min. And A is max minus min over 2. Okay, so we got an amplitude of 3, got a vertical displacement of up to. What's the period? All right, so that looks like a minimum. No other minimum. So I'm going to go to here. How much of the period have I marked off? That's a half of a period, right? So we just go half period. Okay, what's the scale? It's got to be 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So half the period is 2 pi, the period is 4 pi. How much of the period do you need to be able to see? A quarter of it, right? What's a quarter? From the min to the max, right? So I could have done from here, or sorry, from the midline to the max, I could have done there to there. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A quarter, the period then is 4 times, well, 12 was pi, so 4 pi. So you need to be able to see at least a quarter of the period, right? From the min to the max, from the max to the, sorry, from the middle, median to the maximum, from the maximum to the median to the minimum, from the minimum to the median, as long as you can get one of those chunks. Look, the timeline was updated. Okay, minimum phase shift if the graph is that of a sine function. So where are we on here? If this is going to be the graph of a sine function.
Left 5, 5.
Over here. So we go to the y-axis, we find the midline, and we say, where is the closest place where we are at the y-axis going up? So that's 1, 2, 3, 4. So what are we going to say? Left pi over 3. Yes. In your head, I want you to say 4 pi over 12, but out loud, I want you to say pi over 3. Minimum phase shift graph is a reflected sine function. So we're going to have to go here, right? Because there ain't nothing else on there. So what is that? 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's 20 over 12, 10 over 6. 5 pi over 3 to the right. Right. 5 pi over 3. Okay, you do the cos and the reflected cos. Okay, we got it. So what's the magic number? Right? 2 pi over 3. Left? Okay, we good? Could be. I lost count. Like I had it in my head, and then it was 20, but I think you're at 16, right? It was 16 12. Yeah. So here's the cosine curve, right? So all you do, again, right? Everything's from the y-axis. If it's a sine function, it's y-axis midline going up. Positive sine curve going down, reflected sine curve. From the y-axis, maximum, positive sine curve. This is 8 pi over 12, right, which is 2 pi over 3. From the y-axis, reflected cosine curve is a minimum. Okay, I think that's 16 pi over 12, which is 4 pi over 3. Okay, so we got them all there. Okay, fill it in. What's A? Okay, show some work if you need to, right? You got to work out. D is 2. Okay, and so I want to go left. I want to go right. I want to go right. I want to go left. And now we can write our 4 equations, right? What's the only difference between the 4 equations? Well, okay, there's 2 differences. It's either positive value A or negative value A. Other than that, what's the only difference? C. It's a phase shift, right? Sine curve is a cosine curve, right? It's just been shifted pi over 2 to the right. Cosine curve is a sine curve. It's been shifted pi over 2 to the left, I think. So that'd be going down. It's like pi over 2 to the right. So the other one's probably pi over 2 to the left. All right, so we can write out our 4 equations. Is it a theta this time? Yeah. Actually, before I fill anything else in, I could just write this. Okay, so there's my skeleton. Right? They all have the same A value, except the reflected curves have a negative A value. They all have the same B. They all have the same D. Okay. Now I just fill in C. So if C is negative pi over 3, this will be plus pi over 3. Now plus pi over 3 says this is going left, so you've got to make sure, does it say left pi over 3? Yeah, left pi over 3. Okay. Then what? Right 5 pi over 3? And then, what is it? Okay, well, if I've got the value, so it's C minus 2 pi over 3. And minus negative, so plus 4 pi over 3. Okay, so we did 1 and 4 last time. We should do 2 and 3 this time. Okay, questions on that, right? Everybody good with what we're doing here? So you have a curve. That curve can have one of 4 possible equations. A sine graph, a reflected sine graph, a cos graph, a reflected cos graph. When we do these, we're looking for the minimum phase shift. So minimum phase shift for sine is you're looking along the midline for where it first, from the y-axis, midline, first starts going up, that's your sine curve. First starts going down, that's your reflected sine. From the y-axis, maximum, that's your cos curve. Minimum, that's your reflected cosine curve. To verify, okay, so we're going to go y equals negative 3 sine 1/2 theta minus 5 pi over 3 plus 2. We're just going to plug in. 2 is equal to negative 3 sine 1/2. I've got negative pi over 3 minus 5 pi over 3. So what's negative pi over 3 minus 5 pi over 3? 6 pi over 3. What's another way to say that? Negative 2 pi. It's not mine. So half of negative 2 pi is negative pi, and the sign of negative pi is? It got a little more deliberate there for a second, eh? It's like,
Speed the beat up. It's not fast.
Okay, 2 is 2. So it's like 6 of those. Got rhythm, right? I'm not really counting how many of these, but then we'll see if there's 6 more. Okay, do the other one, right? What are we doing? 2 and 4? Or do we do 1 and we do 2 and 3, I think. Okay. Oh, it stopped. Okay, so just plug in. We are looking for this to eventually say at the bottom, what should it say? Well, it shouldn't say anything, it's not audible, but it should read 2 equals 2, right? So basically we kind of know that, hey, this needs to work out to 0, the cosine of something, this thing in here, or whatever. So so it's a half of negative 3 pi over 3, or just a half of negative pi. Which is negative pi over 2, and we know that the theta intercepts are pi over 2 plus n pi. So if it's negative 1/2 pi, negative 3/2 pi, 1/2 pi, 3/2 pi, that's 0. Okay, again, how do we know that? Well, we could just do this. Right? That's your pi over 2, that's your pi, that's your 3 pi over 2, that's your 2 pi. So that's what I do for my quadrantal angles, right? I just think of this curve and just say, I got 0 at pi over 2 and any pi apart from there, right? And same thing for sine curve. Oh yeah, it's 1, at 0 and at pi and at 2 pi and it's 0 at pi, 2 pi, it's 1 at pi over 2, it's negative 1 at 3 pi over 2, etc. Okay, what's next? Determine 4 different equations for each of the graphs shown below. 2 must represent a sine function in this form, and 2 equations must represent a cosine function. Each of them must involve at least 1 reflection, which is the only way we can really get 4. Okay? I'm going to hit pause. Do it. You had enough practice at it. Blah, 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 numbers, etc. So here, I think I graphed it. I've set the window if I did this right, which should then hopefully agree with yours. So if I did it right when I hit graph, I'll just get a little blue dot. Okay, there's the blue one. Okay, and it should match up with that. I set the window to about that. And here comes the red one. So those two are the same. I mean, if they're wrong, they're at least the same. I could be wrong, but I'm consistent.
Never ask them the question.
That's understood. Okay, so that's a D value, right? I think, something's wrong with that D. So the black one, got to work on the D value. I have that in the wrong place. And then what other color is there? Okay, so my black and purples, my cosines are off. So okay, I'm just going to break that. Y equals. So I get minus 1. So okay, 2 cos 3. Okay, so my cos I divided by right pi over 4. Okay, so wait a second. Why is that? Why are those off? I don't know, the sine functions are off. Okay, so go here. Minus negative.
It's 3 pi over 4.
Oh, that needs another bracket in there. Okay. I'm missing brackets here. Insert bracket and insert a bracket. Okay, that'll do it. Gotta wait for watch the blue line.
Plus 5. Yeah, it's going left.
Red line. Okay, so I forgot to close the parenthesis, so I wasn't subtracting 1, I was like multiplying by -1 or something. So there we go, black line. Right, and there's your midline, right? That's why the signs were wrong. They didn't have that midline, they were up too high. And purple line. Okay, so then let's go look at the equations. I'll finish that.
Press on.
Yeah. Okay, so we have 2 sine 3x plus pi over 4. That one was pretty easy, right? Because there's your start point. So it's left pi over 4. Okay, so you're saying left pi over 4. You're writing that the value then is negative pi over 4, so that it becomes plus x plus pi over 4, and then minus 1. Negative 2, the reflected sine curve is starting here. Now, I don't know what that is. There's no, if we had a pi over 12 scale on here, it would be easy, right? Because we would just see that it was 1 pi over 12. What we can easily see, though, is that at 1, 2, 3, right? At 3 pi over 4, okay, and if we put in x, that's right, if I put in x minus 3 pi over 4, it would be the exact same graph. If I'm going to minimize the phase shift, I need to back this up 1 period. Okay, 1 period is 2 pi over 3. That's 9/12. Back up 8/12. We're 1/12. So that's why that equation is minus pi over 12. Okay, the sine function, that's plus, it's left pi over 12. And let's see, let's just clean this off. Lots of junk. Okay, the reflected cosine curve, easy. Sine curve, easy. Harder with this guy. But that's also half a period, right? Like, that's the midline. So another thing you could do is just say, well, that's half. So whatever this is, if I worked this out, well, then you can see that. That's pi over 4. And then that's half of 2 pi over 3, which is pi over 3. So it's like negative pi over 4 plus pi over 3, which is negative 3/12 plus 4/12, right, which is 1/12. So that's right pi over 12, right, or minus pi over 12. Okay, and then what was the other one? This one here. And that's really a quarter of a period. You could do that too, right? So like if you know this guy, that's a quarter of a period. It's a quarter of 2 pi over 3, right? Which is pi over 6. So many different ways that you can come to these values, right? I mean, 2 you just read off the graph. The other two, you can go from a known point and based upon some fraction of the period, you can move over. Okay. Is there more? What's this one? I guess we got to do this. Oh, and then do 4 for this one. Is there more? No, then it ends. Then you've got like 600 pages of exercises. So, yay! And this is also included, right? The using graphs of sinusoidal functions to determine transformations in equations. Is that the end of your booklet? Yeah. Okay. So the second half of the booklet will come later, right? Second half of the trig booklet. So this is on. Yeah. So everything in this booklet, the booklet you have, the test is on all of that booklet.
None of the previous booklet.
None of the previous booklet. No. It says. It's on here. It says from Monday, October 5th, which is the start of trig, up to and including Tuesday, October 20th, which is today, 1 day post-election. Okay, remember, practice, quiz, and review are on Schoology. Review questions are on here. Okay, the quiz is Thursday. Tomorrow we're just moving on, right? Or no, so tomorrow actually is a work period, I guess, really. Well, solving trig equations graphically, so it's that other sheet. But you can start on that. I don't think we need to do anything too extensive, but we can look through this. So we'll spend a few minutes looking through this tomorrow. We won't do a lot. All right, do this one. Let's finish this in degrees. Okay, so I'm going to use the formula here to get D. D is max plus min over 2, which is 6 plus negative 2 over 2, which is 4 over 2, which is 2. A is max minus min over 2, which is 6 minus negative 2 over 2, which is 8 over 2, which is 4. Okay? Now, you could also just count. You're not going to count when this is a real-life scenario and it's like 100-meter Ferris wheel or something, right? You're not going to be counting. You're going to be using these formulas. So it says algebraically determined. You got to show some more, right? It says state the equation. Like, go for it. Just find the values. Right? So this could well say state, right? It's like, who cares? Just state it, right? If you want to randomly graph stuff until you find one that fits, that's not going to work, but, you know. Okay, what's the period? Well, half the period is 360. What's the period? So period is 720 degrees. What's the B value? So it's 360 over the period, which is 360 degrees over 720 degrees, which is 1/2, which is a horizontal stretch by a factor of 2, which means the period has to double, which is good, because that's what it did, right? Went from 360 to 720. So I got A, I've got D, I've got B. Things differ by phase shift. Yeah.
Yeah, that's what I thought.
Oh, right. Sorry.
Yeah, I was.
Yeah, you're right.
Yes.
So I should have gone from here to here. That would have been one period. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12
Times 45.
times 45. So period is 540 degrees.
You're right, raised it.
on there.
So the B value is 360 over 540 degrees, which is, what is that, 2/3? 2/3. Thank you.
This is 1/3 plus cosine.
Yeah, this is not the midline. So I always sketch it in, and then I'll choose to ignore it. Shouldn't do that. Hey, the drop date for this class, so it doesn't show up on your transcript, is the end of the month. Okay? Oh.
That's why I put it down here. But I have given you a from here.
We say it was
The only
2/3?
way you can get like
X?
It's the only way you can get 2/3.
What's D? Plus 2?
I mean, from here to here. Okay, this is 540. You can count 45, 745, 45. There's 56, 40. Okay, you count from here. They're going to be 6 of those all the way to one side.
I just
From the left,
negative sign.
Okay, there's my 4 equations, right? Well, except I've got to fill in the phase shift. Okay, positive sign, reflected sign. Let's just call this sine curve, reflected sine, cos curve, reflected cos. How do they differ? Now I just got to figure out my phase shift. So sine curve, right 45, minus 45. Degrees, make sure there's a degree on there. I mean, actually, technically, the degree should probably go outside the... I think as long as you've got a degree in there, I'm going to be okay.
Oh, okay, so you don't care, as long as it's there.
As long as it's there, and I'm just looking on here to see if there's any particular thing they put in. Now, they put it here, so... technically, you could put it here, right, 2/3. Technically, I suppose you put it here, because that's going to work out too. It's fine. If I'm indicating it here, it just says this is in degrees. So that's got to be degrees, so that's degrees, so that's degrees. Okay.
As long as it's there.
So that was right 45 for the sine. Did I get that right? Reflected sine. So I just get to think, right? Like that's further away than going half a period that way, right? What's half period? 270. So I got to subtract 270. So I got 45 minus 270. Was that 225? So I'm going to go left 225. Cos curve, right 180. And reflected cos curve will be 360 that way. So left 180. All right, is that it? No, it's supposed to have minus 315 instead of plus 225.
Yeah, that's what I put.
Minus, okay, wait, so where did I go wrong here? Oh, wait, so the period's 540. So from here, I want to go back to there. That's, is that 45? Are these 45?
Yeah, these are 45.
Okay, 45. And I want to go 45 minus 270. What's that? I still get 225. So left 225. Okay, now that wasn't 360, so that one was wrong. So I want to go minus, so right 180, so I want to go 270, so I want to go left 90. Plus 90.
Yeah, that's what I did.
Okay.
So the other one's not plus 315 or whatever.
I don't know. It's showing as 315 on my...
Because that's what I just went 1, 2, 3, 4, 5,
Well,
7,
okay.
7 to the right.
Yeah, you could go here.
And 7 times.
So 1, 2, 3, 4, 5, 6, 7 times 45. So that's, but I think the minimum would be to go 225 instead of, so what's 540 minus 315? Was it 315 you had? Yeah, so that's 25, it's 225, yeah. So I think it's x plus 225.
So if you put plus, or whatever.
Minus, I'm probably going to give it to you.
Oh, so either way it would work.
It should work, yeah. As long as if they're 540 apart, it works.
Okay.
I don't know, let's try it.
So minus 315, we'll see.
Okay, so a miracle has happened here, and I have time at the end of a test, and I want to verify these, because I've been asked for all 4 of these, right? Then all I got to do is I can set my window to this. So what do we got? -4 to 7, let's say. So window. And we're going from, what do we got? Say -135 to 495, maybe? -135 to 495 by 45s. -3, that'll work, to 6, 7, let's go to 7 by 1s. Mode has to be degree mode now. Degree, enter. Okay, what have I got? 4. Sine, okay, I need 2/3. Why are you going up?
1 point here, okay?
Okay, so insert 2 divided, so 2/3 x minus 45 plus 2. Hate this thing. So -4 2/3. That was the wrong key. How do you do this? 2/3 x. Okay. Plus 225 plus 225 plus 2. 4 cos 2/3 minus 180 delete plus 2 and -4 cos 2/3 plus 90 plus 2. Okay, and then it should look like that. Red, so it's the next one we're interested in, right? Okay.
Yeah, it says the 315 is the same.
Yeah, so the plus, minus 350, yeah, go right 350. Anything that's apart from these guys by
540.
Well, by 540 is going to be
So you'd mark it
coterminal.
correct? You'd mark it correct.
Unless we said the minimum phase shift. Okay, so I think if it doesn't specify the minimum phase shift, so what did it say here? Blah, 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 4 different, 2.
Not really sure what it is.
It doesn't say.
Doesn't say the minimum, so yeah, I think as long as it worked.